Hello friends, in this video I am going to discuss about the chain drive. Chain drive is also used for the power transmission from driving shaft to driven shaft. So let's start the discussion of chain drive. If we define chain drives, so chain drive generally consists three parts. One is the driving part or driving sprocket, and another is the driven sprocket, and one chain is wrapped around this driving sprocket and driven sprocket. Here so this is the driving part, this is the driven part, and this is the chain. So chain or the chain drive we can define, it is the combination of one driving sprocket, one driven sprocket, and one chain. So here if we want to define the chain drive, so first we have to define what is chain. So here you can see this is the chain. This part is the chain. So this chain we can define as the series of links which are connected by pin joints or hinge joint. So when two links are connected with pin joints or hinge joints, so this is representing a pair. So here this link is in contact with this particular link with same center, and one link will rotate about this particular center, and this second link can also rotate about this particular center. So this particular combination of two links is representing the kinematic pair. And if we are considering number of links are joined by this hinge joint or pin joint, so that particular term is called the chain. Chain generally made of metal, so it is a metallic material arrangement, and in this particular arrangement number of links are connected by the pin joint or the hinge joint. So this is the basic definition of chain, and this chain and the chain drive is generally used for the power transmission. This power transmission we consider from driving pulley to driven pulley. If we are considering this as a driver or the driving pulley, and this driving pulley is connected with the driving shaft, and this driven pulley is connected with the driven shaft, and here power transmission we generally consider from driving pulley to driven pulley with the help of chain. So this chain drive is generally used for the power transmission, and this power transmission we only consider for short and moderate distances, not for the long distances, as we have seen in belt drive and the rope drive having better frictional grip compared to flat belt drive as well as V belt drive. So here we generally consider a rope drive where we want no slip condition or better frictional grip. Now, but in rope drive also there is a condition of slip occur because of very high speed or because of very long distance between the center of the pulley. But if we want no slip condition, in that condition we use chain drives. Because in chain drive we don't use grooved pulleys or flat pulleys. Here this is called sprocket. Sprocket is a toothed wheel, or we can say it is a kind of spur gear, and this chain is wrapped around this toothed wheel. So this particular toothed wheel you can see here, these are the tooth on the wheel, it is called sprocket or spur gear also, and this chain which is the combination of number of links, and these number of links are attached with the hinge joint or pin joint. So this hinge joint and pin joint is providing proper flexibility. So about this hinge joint, these two links can move in a particular direction, so it is providing the flexibility, or it is increasing the flexibility of chain with the help of pin joint and hinge joint. And here this chain is endless. Here chain we can define as the endless arrangement of number of link. One link here, if we consider this is the first link and this is the starting end of the link or the first end of this particular link. So from this end, second link is connected, and from second link the third link is connected. And if we are considering n number of link, so this nth link will connect with the first link at this end point. So here we can say this chain is the endless chain, and this chain drive is the combination of two sprocket. One is the driver, another is the driven, and the chain. So chain drive we can define, it consists one endless chain, and this chain is wrapped around the sprocket. Here this is our driving sprocket and this is our driven sprocket. So this chain is wrapped around these two sprocket, and these two sprockets are further connected with two shafts. One is the driving shaft and another is the driven shaft. So this particular chain is fixed into this toothed arrangement of the sprocket. So this chain will not move because of these tooths. In that condition, we will consider no slip condition for the chain drive. So because of this particular grip, there is a firm grip between the chain and the links of the chain and these tooths of the sprocket. So it is providing proper frictional grip, and this particular proper frictional grip is representing the no slip condition. So this chain drive is useful where we want no slip condition during the power transmission. In rope drive or in belt drive, both the drives we consider slip condition, and to avoid the slip condition we generally use, in place of belt drive we use rope drive, because frictional grip of the rope drive is greater compared to belt drive. But if we want no slip condition, we don't want any kind of slip during the motion, so we generally use chain drive. But one drawback of this chain drive is we don't use or we cannot use this chain drive for very long distances. For that we have to prefer rope drive only. Now let us see how this chain drive is advantageous compared to other type of drive. As we know, here we have seen this is our driving shaft, this is our driven shaft, and from this driving shaft one sprocket is connected, that is called driver, and this sprocket is connected with the driven shaft, and driving shaft and driven shaft are rotating in a particular direction with the proper speed or with particular speed, and this chain is wrapped around this toothed wheel or the sprocket. So chain will also move. So when this driving or driver is moving in a particular direction, so there is a firm grip between the chain and this sprocket, so this chain will not move or it will not run out from this driving shaft or from this driving pulley. So when this driving pulley or the driving sprocket is moving in a particular direction, so it is creating tension at this particular side, because this is our driver, this is the driven. So during no motion condition, here the speed of this sprocket will be 0 and the speed of this sprocket will be 0. Now if we are considering condition of motion, in that condition, at the starting condition this driving pulley is in moving condition, this driven pulley will not move, because this driven pulley is generally moved by getting motion from this driving pulley. So when driving pulley is rotating in clockwise direction, in that condition tension we will consider at this particular side, and it will transmit the motion to this particular side, and tension at this side we will consider lesser than the tension at the bottom side. This T2 is representing tension at the slake side and T1 is representing tension at the tight side, and this particular slake side tension is transmitting the motion to this driven pulley or driven sprocket. And at this particular point also we will consider firm grip because of these toothed surface or this sprocket which is attached with this recess provided into the chain. So this is the construction detail of the chain as well as the work of the chain, and this chain is not used for the longer center distance. Now let us see what are the advantages of this chain drive over V-belt drive or flat belt drive as well as rope drive. So the first advantage I told you that there will be no slip considerable, or here we won't consider any kind of slip because of the construction of this chain drive. Here chain is fixed or chain is wrapped around this sprocket or toothed wheel, so there will be no slip. We will consider in chain drive. Second advantage is here we can use for long and short distances both, but extremely long distance are not preferable for chain drive. Number of shaft and be driven from single chain. Here we can connect number of shaft with the sprocket and it can be driven from a single chain only. Number of shaft can be moved or can get the transmission or can get the motion with the help of single chain only. Another advantage is it is compact because of this shape, and it has small overall dimension compared to belt drive and compared to rope drive. The dimension of the chain drive is smaller and compact in nature. Here you can see in this diagram, this toothed wheel compared to driving pulley and the driven pulley in the rope drive and V-belt drive and the flat belt drive, it is taking less space as well as less material. So this particular wheel is also compact, and whatever chain we are using, that is fitting or it is wrapped around this particular sprocket, so this dimension of this chain is also less compared to belt as well as the rope. So that is why we can consider compact in nature. Next advantage is it is fireproof. Fire hazards are not present. Here during increased temperature, belt drive is not preferable, as well as rope drive is made of different types of fiber, so it is not fire proof. But chain drive is made of different types of metal, it is stronger than rope drive as well as the belt drive, so it is fireproof or fire hazards not present into the chain drive. So this is another advantage. And temperature and environmental condition do not affect their working. See, if we see higher temperature, so belt drive is not preferable because belt is made of different types of fibers as well as it is coated with the rubber, so rubber is not preferable for higher temperature. So during higher temperature we cannot use rubber, as well as we cannot use belts, as well as we cannot use rope, because rope is also made of different types of fiber like cotton during high temperature it will lose its strength, and during fire it will not survive. So chain drive is made of metal, so during high temperature it can survive and it can perform its desired job, as well as for different environmental condition. Like if we use cotton rope, so cotton rope during the wet weather, cotton rope generally soaked lot of moistures, but when we are using chain drive, so chain drive is made of metal, so it will not soak that moisture. So during wet condition or during wet weather, this particular chain drive is also preferable. So it will not affected, or the working of the chain drive is not affected with the temperature as well as the different environmental condition. And it do not require initial tension also. Belt is made of different types of fiber as well as the rubber, so it requires initial tension to provide functional or frictional grip. But this is not made of any stretchable material, so it will not require any initial tension. As well as it will provide high efficiency because of these advantages. These advantages we are considering for chain drives compared to belt drive or the rope drive. So because of these advantages, the efficiency of the chain drive we generally consider higher compared to rope drive and the belt drive. So efficiency we generally get up to 96% in chain drive. And it can withstand abrasive condition as well as high amount of shock. and it can operate in wet condition. As I told you, environmental condition does not affect the working of the chain drive. So these are the advantages of the chain drive. That is why this chain drive we generally prefer for short and moderate distances. But this chain drive has a lot of disadvantages also. So one by one I am going to discuss these disadvantages. We cannot use chain drive where slip is present. So as we know, chain drive we are using because of no slip condition. We are not getting any kind of slip because of the chain which is wrapped around the sprocket, and sprocket is a toothed wheel. So it will provide firm grip for the chain drive. So no slip condition we will consider for the chain drive. But where slip is present, in that condition we cannot use chain drive. And precise alignment required compared to belt drive. In belt drive, if we are using flat belt, so this is the cross-sectional area of flat belt, and this flat belt, so when this flat belt is in contact with this particular driving pulley or driven pulley, so for the belt we don't require any precise alignment, because this particular belt is in contact with this flat surface of this driving or driven pulley. So here it is not fixed. We can remove this belt from this surface of the pulley, or we can consider slip condition here, as well as this belt can run out during the higher speed or during the loose tension or less tension condition. But here in this particular chain drive, chain is wrapped around the sprocket. Sprocket is a toothed wheel, and here we have to provide proper recess into the chain to fix into the toothed wheel. That is why we require precise alignment for this particular chain drive compared to belt drives. As well as it is made of different types of metal, so we have to provide proper lubrication during the motion or during the operation. So frequent lubrication is required for this chain drive. As well as it has less load carrying capacity compared to gear drives. And as it is made of different types of metal, it is stronger and it is creating a lot of noise because friction force is present. That is friction force we can define. This is the link of the chain and this is the tooth of the sprocket. Both are made of metal, and here sharp edges we are considering in this sprocket gear or sprocket wheel. So this particular link is in contact with this toothed surface. So both are made of metal. So when this toothed wheel is moving condition, here it is moving in particular direction, so this chain will also move and it will create wear and tear at the surface of this particular toothed wheel. That is why noise will created here because of the rotation of the shaft, as well as rotation of this driving sprocket, as well as rotation of this particular chain or the link of the chain. And because of the noise as well as because of this particular metallic surface, we can consider vibration during very high power transmission. So these are the disadvantages of the chain drive. As well as one more disadvantage we are considering, it is not suitable for non-parallel shaft. Where we are not using parallel shaft, so we don't use chain drive. For non-parallel shaft, we generally use belt drive. And where precise motion is required, we cannot use this chain drive. Chain drive we only use because of the precise motion. As well as it requires proper housing because there are sharp edges here if we see this sprocket gear, so sprocket gear having sharp edges, as well as this chain drive is also having a lot of sharp edges. So because of this sharp edges, we require proper housing for this chain drive. So these are some disadvantages of the chain drives. And this chain drive is used for moderate amount as well as high power transmission. So these are some disadvantages as well as some advantages of the chain drive. Thank you so much.